Photogrammetry has actually been implemented on a site along M10 highway in Detroit, Michigan. At this site, the Michigan Department of Transportation has been monitoring actually several sites on this highway, and it has been discovered that there are retaining walls that are tilting towards the highway, and photogrammetry has actually been implemented at one of these sites. So basically, photogrammetry at the M10 site included 3 main steps. The first step was data collection, the second step was data processing, and the third step was to analyze the data to see if the walls were actually tilting. So in the first step, there's 2 things that happen: setting up reference points on the retaining wall and surveying them to obtain their coordinates. And then after the reference points were set up on the wall, the crew took pictures from across the highway. Then these images were used to process and create 3D models. And these 3D models were created in 3D modeling software. Once we had 3D models from 3 different data sets that were taken at 3 different points in time, these models were compared to see if there were any movements in between the times that the data was collected. And the results showed that we were able to quantify the movements, and they also showed promise and a good basis to use this processing to monitor other geotechnical assets.
The photogrammetric software was used to generate 3-dimensional models of the retaining walls at different times. These 3-dimensional models corresponding to different times can be compared to identify and measure changes in the wall surface, particularly wall displacement. This image shows the differences or displacements between the wall in March and June of 2014. The color depicts how much the wall moved between those 2 dates. This is a section of the wall. Here is a joint between 2 sections, and this is a different section of the wall, as can be seen here. If we zoom into the section or the joining between the 2 sections, you will be able to see the differences become clearer. This is easier to see in a 3-dimensional model of the wall, in which displacements are shown as the 3rd dimension in this diagram, in this 3D diagram. The 3-dimensional model shows the displacement of the retaining wall in the direction perpendicular to the wall plane between 2 adjacent sections of retaining wall at the M10 site. As you can see, there is some significant noise in the data, but there is also a clear trend that shows that the section to the right, this section here, apparently had a displacement relative to the other section inwards. This is easier to see when comparing the histograms of displacement values for the pixels in both sections. This distribution here shows the pixel values on one section, and this distribution here shows the pixel values in the other section. The dotted lines represent the means of the 2. And it is clear that there is a displacement between both wall sections, which corresponds to a displacement chiefly along this line where the 6-meter mark stands. It is clear that many of the pixels here are displaced with respect to these pixels. But it is also clear that there is a significant amount of noise that makes the interpretation not as easy or straightforward, and needs a little bit more processing. In this case, the wall displacement seems to correspond mostly to rigid displacement that did not affect the shape of the wall. However, it is also possible to model or to calculate the displacement and deformation of the wall in cases where such displacement or deformation is not rigid. Further testing using scaled laboratory experiments to simulate retaining wall conditions and stresses shows that this same method can be used to detect other types of retaining wall failures. In this figure, simulating flexure of a wall, flexural bending due to load in the back side of the wall, is captured by the photogrammetric reconstruction of the wall surface at different times. This can also be easily seen in a three-dimensional model. As you can see, the flexuring of the wall can easily be captured by the photogrammetric method. The vertical or perpendicular to the wall dimension is exaggerated for the purpose of making it easier to see. While one wall didn't experience any displacement, or at least any flexure, the other section of the wall clearly shows an important flexural deformation, flexural bending. Here we can again see the value of trying to apply the methods shown in this section to measuring wall displacement and deformation.